Well, good morning, everybody. Welcome to our first episode of From the Forecast Desk. My name's Steve Abelman. I'm a customer success representative and ancient aviation forecaster from here at the Weather Company. And I'm excited to be hosting a series of podcasts focusing on aviation forecast products and services that TWC provides to our customers. Real quickly, as an overview, we provide several different services. First off, more commonly, the required products such as terminal forecasts or TAFs and SIGMETs for icing and turbulence are products that we provide on a daily basis. But we also provide more specific focused products like hub outlooks for certain customers and hourly winter weather forecast tables. We also provide certified on-site meteorologists integrated into several major airline operations centers to assist with their strategic and tactical decision making. And finally, we'll touch on some of the innovative platforms that are available to our pilots, dispatchers, and for airline operations. So today, our first topic is focused on winter weather events and specifically on the challenge of forecasting precipitation types and why this matters, why this is important. So I'm excited here today to have Senior Meteorologist Eric Pindrock and Aviation Product Lead Chris Oak here today. So good morning, guys, and maybe you can do a little introduction of yourself. Eric, why don't you kick us off?
Hey, good morning, Steve. Good morning, everyone. So I'm a big winter weather buff. I'm excited to talk today about precipitation types and how that impacts the aviation industry. I've been working as an aviation meteorologist with the Weather Company since about 2018. And I've been working as a meteorologist forecasting for several different industries since about 2010. And my interest in weather can be traced back to the superstorm of 1993. I was a kid. My hometown got about 1.5 feet of snow and sleet, and school was closed for about a week. And I was always fascinated that weather could close school. And I wanted to know why, what could the atmosphere do to make school get closed for a week or so. So just a little bit of intro to my background in weather.
Thanks, Eric. Morning, Chris.
Hi, Steve. Thanks for the intro. My name is Chris Oak, and I've been working with TWC since 2010 full-time, and my background is in meteorology. After starting in our meteorology operations department, I did work in quality assurance for a number of years at the Weather Company before starting to lead the aviation product offerings here. I do think that kind of helps with keeping our focus on the quality of the product as we're developing things for our partners, and I look forward to continuing that.
Great. Thanks, guys. So, I think to get us started here, I think we're better than ever at forecasting winter weather events, but the complexity of forecasting whether snow is going to be wet snow or dry snow, or even if you get into ice pellets or freezing rain, we have a very complex process to take a look at how we do that. So today we're going to talk a little bit about the science of forecasting precipitation types, how it relates to airline decisions, and what airlines do during winter weather operations. So I'm going to start off with Eric here, and I'm going to ask Eric. So, when there is a potential for multiple precipitation types during an event, what do you look for to differentiate the predominant or the most impactful precipitation type?
Yeah, so I would say the most important tool that meteorologists have today would be looking at profiles of the atmosphere, which is basically just taking a slice of the atmosphere from the ground up into the cloud. Sort of a visual way to think about that is if you have a layered cake, you take a cake out of the oven and you put multiple toothpicks into the cake, pull out the toothpick. You want to make sure that the cake is baked, right? You want to see what the different layers are like. And so each of those toothpicks are what we meteorologists are using to sample the atmosphere to see what the weather conditions are like. So what are the winds doing at cloud level? What are the winds doing at the surface? What is the temperature and the dew point at the surface versus 5,000 or 10,000 feet up? And once we get as complete a picture as we can with weather conditions at various levels of the atmosphere, we can determine, well, is the cloud going to produce all snow? Is the cloud going to produce maybe a mixed bag of wintry precip, ice pellets, freezing rain, or just plain rain? And so in short, I would say those samples of the atmosphere are very crucial for, again, determining precipitation types.
Thanks. That's a pretty fitting analogy considering how much cake and cookies we've been eating this time of year. Anyway, so I'm going to switch up to why do we think, behind the scenes, airlines are always talking precipitation type and changes. And why do we think this is so important? I guess this is a question for both of you. What is the difference between ground operations during de-icing and de-icing during light snow versus ground operations during a heavy snow or precipitation freezing rain event? So I'll start with you, Eric.
Yeah. So with a light, fluffy snow, typically you're going to see temperatures across the whole atmosphere be well below 0 Celsius, well below freezing. And so that will give a texture of, again, a very light, fluffy snow. It's very easy to kind of brush off. It's easy to de-ice off of a plane wing. And so in most cases, it's very easy to get the plane de-iced and going. But when you have ice pellets or rain that freezes on contact with a surface like a plane wing, that can be a little more dense. And if you think about an ice pellet, it's a small ball of ice, which has a higher density than a snowflake. And so to de-ice and to get rid of that ice pellet, to get rid of that frozen rain that might accrete onto a plane, it's going to take more time. And so obviously, determining whether we're going to have a light, fluffy snow affect an airport or ice pellets or freezing rain is going to help to determine for airline personnel and for airline management what is going to be the potential holdover times for flights during certain wintry P-types, precipitation types.
Thanks. And Chris, I know you've been out in the field a lot with our new innovative products that we'll get to in a minute, but what have you heard in your engagement with customers about the importance of holdover times and how forecasts of holdover times and forecasts of precipitation types are relevant?
Yeah, a lot of our airline partners are trying to determine weather impact. And one of the main issues is if things are changing quickly or if something unexpected is happening when they may have planned for a different scenario. We can track some of the holdover times once you're sprayed with any kind of fluid in the products, but that's something coming up on the roadmap.
Let's talk about changing conditions, because I know winter weather forecasts don't always go as planned. And so, I'm going to ask you, Eric, first of all, and then I'm going to add some information too here. How are our forecast changes communicated to our customers? When model conditions suggest a forecast may not go like we thought it was going to go, how do meteorologists make a difference for our customers? And Eric, I'll give you a shot first at this.
Yeah, so at the Weather Company, we have various teams of meteorologists that are based across the US and also across the world. And we're constantly communicating and collaborating. And so if model guidance and if observations suggest that the forecast might change over the next several hours, we are working closely together with meteorologists that are embedded in our airlines, with meteorologists embedded in other offices. And we're working to really edit our forecasting database called the Forecast on Demand in our proprietary systems here. And when we edit our proprietary systems, we're able to change the forecast so that when we're writing TAFs and we're disseminating TAFs for our customers, the TAFs are going to be able to ingest that new information and that new thinking from the model data and from the humans itself. And then, of course, the meteorologists at the airlines and other places can help communicate that forecast to airline managers, airline leaders. So then that gets translated as quickly as possible through the operation, allowing for a smooth interpretation of the changing weather conditions.
Yeah, changing forecast conditions are very important to airlines. They deal with very tight flight schedules, and potential impact causing irregular operations is always top of mind for airlines. One way the Weather Company can help with this is by using our probabilistic forecast data along with our most likely deterministic forecast. This allows airlines to prepare for the most likely scenarios while having insight into the risk of potential extreme scenarios playing out. And an example of this could be something like a scenario of a couple inches being the most likely outcome, but maybe there's a probability of an icing event occurring if certain trends continue in either our model or model forecasts, for example. So that may be something you want to know about and try to be less reactive when they occur. When speaking about forecast changes as well and how they're communicated to our customers, those changing weather conditions are really important to all of our customers, and the way that those are relayed are often focused for airlines. We can disseminate changes in forecast on demand in our TWC TAFs directly through our applications, and we're working to embed forecast briefs directly into that experience as well. When forecasts are changing, it's important to keep the whole operation up to date on the latest forecast to help with coordination amongst critical stakeholders at the airlines.
Yeah, I was going to add a little bit about Forecast on Demand. Forecast on Demand is sort of our proprietary, output from multiple weather models with meteorology oversight. We're getting hourly updates of all the important aviation weather impact variables, from precipitation type to winds to temperature. And this is all available via API and is becoming more and more popular for our customers to integrate into their own systems. And so, Forecast on Demand is, really improving the output. And that's really these hourly changes changes are really highlighted in that product really quickly. So thanks for that information. Good stuff. Let's shift to Maverick Dispatch. And so, Chris, I know this is your baby and you're doing an amazing job with this, but our tool, Maverick Dispatch, amongst a lot of different things it's doing, is trying to develop an insight for de-icing operations. Can you give us an idea of, what we're developing and why?
Thanks, Steve. For folks not familiar, Maverick is the platform which we have built Maverick Dispatch on to better serve the needs of our IOC and flight following stakeholders. It's actually our successor to Fusion, which many of our customers use now to help run their operations safely and efficiently. Maverick will have a number of embedded insights directly in its workflow, including a new de-icing insight, which we're discussing, which will analyze past, current, and forecasted weather conditions and give a quick, succinct view of potential de-ice risk and its intensity. Our customers are always trying to stay ahead of the weather, and one way we can help with this is through this type of insight. The Maverick alerting engine will quickly identify conditions which may lead to a de-ice scenario and alert dispatchers to this issue while showing relevant weather conditions and forecast conditions. On the roadmap for Maverick, we will track aircraft along with other surface insights to be able to get a view of how de-ice operations are progressing on the surface if there are more bottlenecks developing.
Yeah, Chris, that's really cool. I think this concept of insight is something we're going to be talking about a lot, as we go forward with these podcasts. And, I think your example of de-icing situation in the southern city that's not accustomed to de-icing is a very different situation than what we have, in a northern city. And not only will the forecast, show that, but also the insight will help the decision makers make those decisions. So I'll throw it out there. Any last words from either you, Eric, or Chris?
I was going to say, too, I think, part of the reason we had done Maverick is to distill a lot of data that we have into, say, an insight or something that we took a lot of the work already upstream ahead of the dispatcher. So we had a lot of feedback of volume of data that we send down to individual stakeholders at the airline. And I think through FOD, through Maverick, through other tools that we have, the forecast science team here and the product team are very hyper-focused on trying to distill down what people are really trying to use as a decision marker, and then be able to, get these forecasts and get the best information down quickly to help decision making. So I think in the past, there's just been a lot of data when you're in an irregular, operations type scenario, you can't really spend a ton of time analyzing every piece of data that's coming out. You need some of that summarized quickly for you, and then, assist with decision making.
Absolutely, Chris. Thanks. Eric, any last thoughts?
Yeah, I'll just say that I think the best way that the weather company can differentiate ourselves from other sources like the government and other private weather sources is we have our high quality FOD weather data combined with our human meteorologist expertise. And together that data with human meteorologists can really help deliver a high quality weather forecast that could be disseminated by airlines and by other customers that want to use our data.
Yep. Thanks, Eric. Really appreciate that. And thanks to both of you, Chris and Eric. Really appreciate the time and some good discussion. And thank you. And until next time, look forward to getting together again in a month or so. Thanks again.
Thank you.
Thanks.